So basically, they consider anything 45 degrees self-supporting. So if you have your orientation on a part 45 degrees, it'll build without support. If anything less than 45 degrees, to support that overhang, they recommend having support structure. That's all going to be as you guys get more confident, the more you start using it, you can start playing around. You can go down to 35 or 30 degrees. You know, try pushing the limits, go down to 25 degrees, don't put any support in there. Don't expect a really nice down skin surface without support, because it's basically, it's going to have a lot of excess powder melted onto it. And the surface texture is going to be really rough. EOS recommends, if you're going to build a diameter and you're growing it vertically, anything larger than 8 millimeters, they recommend a support structure inside that diameter. And the reason for that is, I think they got some pictures of samples, but what happens is you can grow it without the support in it, but you're not going to get a round hole. You're going to get more of an oval. That down skin at the top is going to sag a little bit. And then, in that same sense, you have to think about, do I even need a round hole? Because the reason that the hole's round is that's how you manufacture it right now with the drill bit, get a round hole. If you're making, for example, a hydraulic cavity or internal cooling channels, do they have to be round? Probably not. That's where a lot of people are starting to think outside the box. We're starting to see teardrop holes, diamond-shaped holes, just so you can grow them without any support inside there. Overhang structures, EOS recommends, and again, you guys can play around with it. I know I have, and I know what the limits are, but they recommend 0.3 millimeters. Anything over 0.3 millimeters overhang, they recommend put some support there.
So, quick question. When you say support, is that external support comes to the system, or just like?
Yeah, I'll show you. It's in Magix.
Okay.
You generate the support. You'll see the support actually attaching to your part.
Okay.
Yeah, we'll get to
Okay.
that. Yep. It's all automatic. Here's an example of a part and why you're going to need support. First of all, you need the support. Like number one, you need it there to attach your part to the build platform. Without that support, as the recorder arm comes across, it'll just wipe your part away. There's just too much friction. If you look at your support number two, which is in between there, it's needed to dissipate the heat. So you got a very thin structure, the top. If you were to try to, let's say you had that as a solid, I don't know how you would do it, but you would be putting so much heat into that little thin area that you would either warp it, discolor it, your mechanical properties would be terrible in that section.
So heat sink.
Yep. And not only is it a heat sink there too, but keep in mind this is all a heat sink down here too. You're transferring all that heat out of your part. And then if you look at number three, you can actually manipulate the support to come out at an angle to support your overhang. The reason you want the coming out at an angle is you don't want this support coming down here on top of your part.
Yeah.
That makes no sense, because then now you got support. You got to clean up that area and you got to clean up this area. Just in Magix, you would come in, put an angle support in there, get it off your part.
And that's a very tough. So the supports need support as well, or you ever have that situation?
Yeah, sometimes. Yeah, you don't want to have too much angle on there because you're defeating. Yeah. Yep. You want to keep everything as simple as possible. And there's number four. The support must be easy to remove. If you have, like number four, if you have the support there and you can't remove it, your part's no good.
So the support is built by the same material, right?
Correct. Yeah, same material. It's the exposure settings, the way it calculates it is different. So the support itself is supposed to be brittle. you can set it up, you can have teeth, so you can break it off real easy.
Okay.
And then what they're showing with 5 is you want the support to, you don't want to trap too much powder. Powder is expensive, plus powder can interfere with, could be a safety issue when you're trying to remove the support. You want to keep areas where you can get that powder out of there. And there's some ways, I'll show you some ways when you actually start using magics. There's a couple different, the main support 90% of the time you're going to use is block. And it looks just like what you see there. And then from there, there's a bunch of other features they have fragmentation on. I'll get into that a little bit. The fragmentation is these gaps that you see. Those gaps make it easier to remove that support. You get a chisel in there, you get a hammer in there, and you can pop that support off a lot easier than if it was just solid, if you didn't have fragmentation. And then in this block setting is also where you can change your properties for your hatching, you know, how much spacing you want in between the support. And again, these are just more of your, so you got XY offset, keeps the support away from the outsides. You know, again, it's all to make it as easy as possible to remove that support. Z offset. Z offset, like I said yesterday, the laser goes through 3 layers of material. You can have it, so even if you think it's only going through the one, so you can have it so the support doesn't penetrate into the bottom of your part that much. You can actually have it so it goes away from your part. And then people say, well, how is it going to attach to my part? Well, the laser's still going through 3 layers. I think default is going to be 2 layers into your bottom of your part. You can actually put 0 in there, you can actually put a negative number in there. And what that's doing is, even though you have negative number in there, in theory the part's still going to just barely be hitting on your part, and it's going to be easier to remove that support.
Because even when there's 3 layers of powder over it, you can do well and we're still getting contact with the
Correct.
correct.
There's still enough heat. And you can, like I said, you can work with both the upper and lower offsets. No support offset is off of your walls here. If you have a wall, you can put a no support in there. I think I told you 0.3 millimeter overhang. You can go, I've gone as much as 0.8 millimeter. I wouldn't risk going anything past 1 millimeter. You get a lot of overhang, and what happens is this downskin starts drooping a little bit. If that's fine for your part, you know, that's good, but you know, it all depends on who you're making the part for and what the customer wants. The other thing I find that this really helps out with is if you do have to post machine this, and you hand this to a machinist, and then they ask you, all right, how am I supposed to remove the support right here without touching the sidewall? Well, if you give it a little offset, give them a little room there, then that machinist can take an end mill through there without having to touch that wall. This is the hatching that you would use in the block support. I think default is 0.7 millimeters, and that is the spacing that you see in between there. And when you do the hatching, you can't control it. The hatching is basically that width of that wall is just one laser pass. So I think it's like 10 thousandths, 12 thousandths thickness of the wall. Like I said, you can't control that. It is what it is. You can change the rotation of that hatching. And then you can see all the different settings. We're not going to be getting into all of that. But there is the fragmentation. When you turn it on, off, you can even do it with the border. Again, if you do it like above, that's how you want it to look. What happens is you got spacing to put the chisel tool in there to help break the support out. And the other good thing about fragmentation like that is you can actually squeeze it between a vise or squeeze it between pliers. And with that spacing, it's going to help move, and it actually helps pop those supports up. The teeth, this is something, again, I'll show you some basics, some rule of thumb, but here's where you really can start playing around with the teeth to easily remove it. Because if you don't have any teeth in there, for example, you're just going to have a solid support there. But if you have the teeth, you can see, you can tell at the top length. Like I only want the top length 0.1 millimeter. And again, so in the advanced stages, you got an angled support, you can do a projected support, you can make a thick support, you can do perforations, you can even do gussets. I barely ever see anybody do gussets. So there's some, and you'll have all these slides. There's some good rule of thumb. I think what you see highlighted in red is basically your defaults. You can go in there and play around, for example, on titanium. 0.7 sometimes is not strong enough. You got to make that like 0.6, 0.5 hatchet. It's just too weak. The titanium has got so much stress, it just wants to curl up off the part. EOS print 2, we're going to skip EOS print 2. And I'm going to actually go through
So before you start the first layer, do you put any support at the
yes, the first layer, that's where your support is going to be, is that very first layer. So you'll see it a little bit more here when I throw up a practice part. You'll see the support being generated, and your very first layer is going to be your support.
Between the different levels, between 22, 23, 24, it's all the same type of user interface type stuff.
It is. There's some features on each version that actually makes it easier for you.
Okay.
But basically, the thought, the way you do it is the same. So this is I'm using a 290 build processor. So this is a 290 build. You can see my no build zones are right here in red. That is where the bolt holes are. I'm going to just create a simple block.
The extreme left side of the bar is getting cut off there.
Oh, is it?
Yeah.
Yeah. No, I can do that. How's that?
Yeah, it's got it.
You can see it's like, yeah, it's like
It's getting like an inch off each side.
So the first thing I like to do when I bring a part in is you can see this bottom ribbon down here. You can make a custom ribbon. So some people who really get into this will have it so they just follow this ribbon right in order. This is what I do next. I don't use it enough to have a custom ribbon, but I usually bring the part in. First thing I do then after that is I will position it, which you can do a translate. I do have my default set, and then on a metal machine, 4 millimeters is usually a good height to start it off with your build plate. You can go, you can make that Z height whatever you want, but just keep in mind, the higher you make that, the longer your build is. You don't keep that to a minimum. Some people put solid support. or just extrude that model to be a solid. They'll give it a little extra 0.5 millimeter of length because they're wiring that off with wire EDM, so you're not very little waste. Well, so if you think about it, if you go from 3.5 millimeters, you're saving 3.5 millimeters height, you're saving quite a bit of build time and material. All things to keep in mind for the future. But I think with supports, 4 millimeters is a good starting point. So right now, my part is 4 millimeters off. The build platform, after setting up where I want my part, then you would go into fix, do the fix wizard right here. Don't do the automatic fix, because sometimes there are things on your model that you don't want fixed. If you got 2 separate parts, you don't want that fixed. If you purposely know you want a living hinge, or you want you're making a hinge, or you're making a joint, or something, gears that you want movable, you don't want that fixed. So I never use, and I tell everybody, don't use the auto fix, I always use the fix wizard. And when you go into the fix wizard, you'll see your choices here. You can, this is where you can just kind of experiment. I'm just going to show you the basics. We're in the diagnostics. You can come down here and hit this update button. And once it's updated, you can see it's going to show you everything that Magix finds wrong with your support. Everything is checked green, meaning it did not find anything wrong, which I would suspect that because I just drew a simple block. The main thing you want to look here for is you can check and uncheck what you don't want it to check. So these bottom 2 are not the most important. Sometimes you're going to have overlap triangles you just cannot fix, or intersecting triangles. So you can actually uncheck those, just ignore it, and then do update, and it's going to update everything. But the most important thing here is the shells detected. You know, you should only see 1. There are times, like again, if you're making a gear or if you're making a living hinge, you're going to have multiple shells there. Then that's acceptable. But 90% of your time, I guarantee you're only going to want 1 shell, and that's going to be your first biggest thing you're going to look at is the shells. So then you would just, I don't need to do it, but then you would do an update. You would say follow advice. If there were some errors, you would hit this button down here that says follow advice. You hit it. It's not giving me anything because I don't have anything wrong, but let's, actually I'll force it to have an error. I'm going to delete that triangle. So there's, that triangle has been deleted. In Magix, whenever you see red, that means you're seeing inside your part. You never want to see red. So now if I come up here and I do the fix wizard, update, boom, it's detecting, you know, 3 bad edges. It's detecting a hole. So now you can say follow advice. And then here's where you can hit the automatic fixing of it. Hit it. It's going to show you what it did. It filled the hole. And then I come up and I'll hit diagnostics again. I'll say update. I want to double check. Everything checks green. I'm good.
So is that the same procedure when you import from different, like for example, SolidWorks?
Yes.
Yeah, same procedure.
So it's
Most. Yeah, I was going to say most of your CAD files or most of your CAD systems now do a really good job converting to STLs. If the designer or whoever modeled up that design, if you did a good job, you should rarely see errors. But you do once in a while get a model from somebody who might not have drawn it correctly. You know, he's got gaps in areas, and so then when it tries to convert that and put triangles everywhere, you know, it's going to have some missing triangles or overlapping or areas that it just couldn't figure out.
That's like always to like fill with the material, like the whole thing.
So
So like here, like when you like do this mixing here, that's the shape. It's like add material to like foam and like, you know, it's like solid.
yeah, so it's basically just making sure everything's watertight.
I mean,
So it
so
did.
it's not like fix, like.
Yeah, it didn't actually add any material inside. It's just making sure everything's watertight, just you can't see through it.
find maybe like designs to like remove. I mean, but I don't know, but like this is.
Okay, I mean, I'll show you some more.
Oh.
So, I mean, you can, sometimes errors are pretty gross, and you bring it in and you're gonna see it's got, I'll delete that whole side, and you see that it has missing triangles. You know, you can go in there and you can fill them yourself without even having to use the fix wizard.
Oh, so I think what he's thinking was like, what if you intentionally put a hole in it? Like you have
Yeah,
a
we can
proper
even
hole.
generate a support, right? Like a colon,
Yeah, but if you put an intentional hole in it, then it's okay. But I think that just wants to be able to render the surface.
Yeah, so it's, if you intentionally put a hole in there, it's gonna put triangles around that hole.
Yeah. To mesh it.
Yeah, so it's not gonna see through the part. I get it. So, I mean, we can go in there,
Like, so the hole won't be a mistake. It would be like a real
Yeah.
hole, but
Uh-huh.
intentional hole.
no, if there's an intentional hole, it's not gonna fill it in. There's ways to, sometimes you'll get, it's a lot of just playing around. You can create, you get a part and it's got such a huge hole in it that Magix can't fix it on its own. You can go in there and put bridges in there. You can start filling it yourself, and then you can say fill the holes, and then Magix can figure out where you want filled in the hill. There's a lot of things. You just gotta play around with it. Triangle reduction, sometimes if you get a really complicated part, a lot of surfaces, curves, lots of triangles, it will bog your computer down. The more triangle, it's just, you move it, and it takes like 20 minutes for it to remesh or to render your part again. You just go crazy. Or you can go in there and you can actually do some triangle reductions. You can smooth out, because you'll go crazy sometimes. It does have some CAD features. You can unify your parts. You can take shells, convert them to parts. There's a lot to play around with, experiment. But the basics though is you want to fix it. And then after you fix it, we went to our position. Now we're going to go into, let me just show you a little bit about the position too here. We can, so in the position here, you can also do, you can make copies, you can do rescale, you can mirror. Let's say I look at this part and I want a different as my down. So you can come in here and indicate what plane you want as your down. Let's see here. So flip it. And if you do that, then you're going to have to come over here and redo your, because it is going to change your, where it is in the platform. A good thing with the newer Magix now, so Magix 24 that you guys will have, it's got a orientation optimizer, it's got a comparator. So if you have a part and you kind of like, how am I supposed to do this part? You can actually come in here and do an orientation. You can do a compare. You can even, it does your 3 basics, which is your Z height. The shorter it is in Z, the faster you build it, so it always looks for something like that. You can also set it up for support surface, the least support.
Yeah.
And then you can also set it up for max XY cross section. I didn't really talk about that. The reason that's important is if you have an XY cross section and it's consistently the same throughout the build, your heat's going to be the same. You're not going to have like a little small cross section down here, putting a ton of heat in, and then you have a big cross section up here, and you're cooling the part down. Your mechanical your material properties are not going to be the same as it is down here as it is up here. So your objective is to always keep your XY cross section as even as you can. I know it's not possible, but you want to try to keep it as even as you can.
If not expanded.
Yeah, just for mechanical or material properties, you want to keep everything even. And that's what max XY is. Let's say you have a orientation that you think is the best, you can add that in there, so then you'll have 4 comparisons. You can have 5 comparisons if you want. You can have as many as you want. And then you can come in here and say compare. And then Magix is going to show you the differences between your Z height, which is your fastest build, it's 50 millimeters. It's going to show you max XY section, which is the way I have it now vertically, but you've got double the height, so you're going to have double the build time. And then you can also compare your how much support volume you're using.
So the middle one is the max.
Yeah, so the middle one is showing you your best orientation for support structure. So if you look at your support volume, it had 0 because Magix is not smart enough to know it. It threw everything on 45 degrees, so it says you don't need any support. But you still need a little bit of support to tie the part down to the platform. So Magix isn't smart enough to know that. And then if you look at your support volume on the other two, you got 20,000 millimeters cubed, and then you have 220,000. And then you have 10,000 millimeters cubed on the, so that's all things to consider. I also look at the volume box too as for my volume.
Yeah, clearly in the middle, the support volume is large, but it's not calculating it.
Now there is a little bit, you're gonna have a little bit. Where you would have a little bit of support is right, you would have to have a little bit of support right here in this corner to tie that part down to the build plate.
Okay. So it's not extending all the way to the end of the build?
No,
Okay.
it's not, because it's all self-supporting up there.
Gotcha.
You just need that little bit to help hold it down as it's starting to build.
Oh, I see.
So you're still gonna have a very small volume. The only problem is your part, yeah, the heat's not gonna be too bad. The only problem is you're gonna have, because you're building on a 45, you're gonna have a stepping on that outside layer. So your surfaces are not gonna look as nice as your Z height and your max XY section. So all things you have to keep in mind is what's most important to you? Is it the appearance of the part? Is it the mechanical properties? Is it how fast you build it? All things you got to keep in mind. I mean, if it's material properties, yeah, sometimes you're picking a weird orientation.
So one thing is what I don't understand. Visually, when you see number 2 in the middle one, it say 0. That means what happened? How the material hold? For example, the power.
No, that's what I just getting at. So in reality, the middle one is going to have a little support there. Magix just isn't smart enough to realize you need that little bit of support to hold it down. But you do. It's not a lot though.
Okay.
The middle one is still the best for support, at least support. So then you can either click on what you want as, so I'm going to say, okay, this is the one I want. Where is it? And then it's going to automatically change your orientation. Good thing with, Magix, should we bring this down a little bit? Is there's an undo button, and you can undo, I think it's a couple hundred, as long as you don't exit out. So then, I decide, oh, I didn't want to do that. You can just undo it. So now I will go into the sports generation, and here is where you just go over. For now, you guys are just going to do generate support. And there's the support. So now when I come take a look at it, you can see my hatching. And then off to the side is going to be your support pages where you can actually make your changes. show you. It doesn't like it. So full screen, so then you can see most of it. Here's where all your options are with that. So you got your block, and mine is defaulting to 0.6 for some reason, but here's where you would change it to 0.7. And then you would say regenerate 2D, 3D, and you can see the spacing opened up a little bit. You can change the rotation angle if I wanted 90 degrees. So what did that say? And you can watch the hatch. You can see the hatching rotate. But the reason you don't want this is something when you have your part in there and you got a recorder goes, I told you the recorder arm goes from right to left. The recorder arm, you don't want your part contacting parallel with the recorder arm. It's a lot of surface. Let's say you have a big part. If your parallel as the recorder arm comes across, it's a lot of surface to contact. So rule of thumb is you want as little minimum contact. You want a single point of contact. So if you have like a diameter, it's always going to be a single point of contact. So if you have a square, good rule of thumb is just twist it 5 degrees. Or and then by doing that, you're always going to have a single point of contact at the corner.
Yeah.
So that's what the people will actually think like that for the support structure. So right now, if you think about the recorder arm coming across, it's going to hit that, parallel. It's like instead of perpendicular.
It's like you don't want to have a wave hit flat wall.
Yeah, you don't want to hit that flat wall. There's a good chance it could hit, bounce off. There's a lot of things it could do. So this is where, some people actually take the time and they'll look at that support structure and figure out what the best orientation of that is. That's where you can mess around.
Would you also suggest that for the actual part?
Yes, yeah.
So you have to take that into account.
Yeah, so I would not, I don't change that here in Magix. I usually change that in, for example, you will change that in your PSW.
Yeah.
Like I'll just leave it anywhere on this build on my platform, and then once I bring it into the software that you actually put it into the machine,
Yeah.
that's where I'll tweak it around and
Make
change
sure
it.
both are.
Yeah. You can't, the only thing PSW does, it doesn't allow you to change anything with the supports. Supports are all done in Magix here. A nice thing feature that 24 has, which 21, your older versions did not have. So let's say I want teeth in here. Just hit this little exclamation, or I think it says for information, and it lets you know what A, B, C, D does.
You get
Comes in handy. Yeah.
Both at the top and bottom, right?
Yes, if you want to. I'll just, you don't even see it, but there's a little circle with a little eye in it. Just hover over that with your cursor and this little, comes up. And that goes for anything. It goes for fragmentation. You can hover over it and it's going to tell you, all right, here's what you're filling ABC in, that's what it's going to do. Perforations. It's going to show you, all right, here's your options, and this is what it does when you fill in the blanks.
Easy to remove the bar.
Yeah, perforations are used, a lot of people use perforations if you have a really big part and a ton of support. People put
Remove.
perforations in there to get that powder out. They want to save as much powder as they can.
Easier to remove.
Oh, you're right, because those gaps will have powder in it,
Yes. Yeah.
and you can reuse it.
Yeah, so if you have 0.7 millimeter hatching, and you got a lot of big chunk of it, there's a lot of powder in between there.
And then you dispose of that in some special way?
Yeah, I usually shake it off, shake it in the machine. So you're gonna take the build platform out, stand it up on its side, kind of give it a little shake, get that powder out of there. Back to type. You have block, and I've seen point support used. I've seen the volume support is basically solid support. I've seen cones. Cones are just as you see there. You can give it a diameter at the different diameter at the top and the bottom, so it tapers up, makes it smaller, makes it easier to remove. Volume support is just going to make that, as you see, there's no hatching, it's just going to make it solid. Extremely difficult to remove, unless you have a wire EDM. Point support, just like it says, it's just a point. I've seen people use, so you got your different, web contours, but 90% of the time, 95% of the time, you're going to use block. And we'll finish up with that. So now at this point, you have to come over and you say, we're going to export the support. Actually, in your case, since you're using the processor inside of it, I think you're still all right, but just as good habit, I would still save this.
Okay.
Yeah. Even though you're using the build processor, I would still be, as a good habit, I would still save the CLI files.
Right, you can always edit it again.
Correct. Yep. This layer thickness. A good thing to remember, unless you have a monster part, just put 10 microns in there.
Layer count express much.
Yeah, just put 10 in there. What that does is, no matter what material you use, you're always going to slice at an even number. Because there's sometimes, depending on the material, you can slice 20 microns, 30 microns, 40, 50, 60. So let's say you had 30 in there, and
That's a layer for each build.
yeah, so let's say you're doing 30, but your material does slicing at 50, it's not going to be able to match that. So if you always leave that as 10, you're always going to be good no matter what layer of thickness you're doing.
And this only corresponds to the build of the support, not the actual part.
No, it's the actual part too.
Everything?
Yep, the whole thing.
How low can you, because it's limited to the resolution of the layer.
It's limited to your resolution, yes,
Which is what?
whatever your material is. So if you're like MS1, I think you have a couple options. I think it's 30, 40, 50, something like that.
40.
Is it 40? Yeah.
Okay, so you have to know that before you actually.
So, and you have, I think I saw you guys actually have 3 options for your MS1. So you have speed, performance, and then top speed. And I think top speed might be even thicker, might be 60.
And that's all information on the actual power.
Yeah, that's actually, yep, I have parameter sheets I'll be handing out or leaving behind. So you just say it that way, then you say, okay, make sure you save it where you want it to go. I'm just going to throw this into a test
So,
folder.
you already bought, okay.
So there's, and that's when I say, okay, it saves that, so it's just save my CLI. And another good habit to do it. All right, so you just exported your support, save your part, because when you save your part, you never know what you might have changed orientation-wise. So when you save your part at the very end like this, you're saving it in the orientation that you built your supports in. There are times where if you don't do this, and you saved and you load your previous version before you change stuff, so then when you bring that in, your support, it's not going to match.
Yeah, it's all.
Yep. So all habit of saving both, so then I'll go in here and I'll save my part. I like to save everything in the same folder that I used, so when I go to look for it, I know exactly where it's at. And it's the box OM is my CLI file. I already have a box, I just call this box. And then when this is all done, then you'll hit exit. And it's still showing you the support on there, but you can't make any changes to it. I will show you one thing. Let's say you realize, okay, I want to make some changes to my support. Just go back into support generation. This time you don't say generate support, because any changes you made to your support, if you hit generate support up here, it's going to override any changes you made. So come in here and you say manual support, generate support right there. By doing that, it's not going to touch anything that you have made changes to. It's just going to go back into the support page so you can make changes. In there.
Question. Our 3D printer, it's not working with only with Magic, right? Sometimes I use like Autodesk Math. Yeah, so I know that they have like a lot of printers. So I know they have like they are very good at generating an Excel code. So I can still import to the machine, right?
Yeah.
And second question, like that is have like we're working with the data structure. That have it's a strength to that.
It does. I can look see what you guys have once you get your license. My guess is you don't have lattice structure turned on. It's an extra module. Yeah, I have it.
So that should like you can.
Yeah, it's an extra module you buy for Magics,
Okay.
but you can. It does have the option for it.
Okay.
So you can design the lattice.
Yeah, you just have to like print the like 2D model.
Yeah.
Then you have to like select what you want to like to change to like this. So it's very easy. Just
No, Magics has a very easy structure, so it's actually right here.
yeah, just
Yeah, Magics, you can have a shell, you can have it just last the inside, just last the whole part. The other thing I really like about Magics is it gives you a ton of basic lattice structures, which is what I really like about it.
Nice.
You got all these
24.
choices over here.
Out of curiosity, is the diamond structure it lists there, is that the sheet diamond or the skeletal diamond? Just because that's what we're using for, we're using the sheet diamond. That's the skeletal.
Yeah, yeah.
This is in 24, right?
You guys don't have it. It's an extra module.
extra.
Yeah, it's not overly expensive. I mean, if it's something you guys want to add on down the road. To me, of all the different lattice programs out there, I would just buy the module for Magics. I mean, it's for the cost and the ease of use. It's not bad. Because I have MetFab too, and I just find it a lot more difficult. I mean, there's probably a place and time for it, where if you just do a simple lattice structure, Magic's the best. I'll get on that. We don't need to, I just wanted to show you that. I mean, Magic has quite a bit. They even have a simulation, as you see up there. I have a simulation module turned online.
To do the build simulation?
Yes. Yeah, it will. It doesn't actually simulate the build. It simulates where your stress in the part is going to be as it's building.
With heat and everything.
Yep. So it's going to show you cold spots and hot spots. And it will even put in some predetermined where it's going to deform for you.
So how about the layer?
As to
Yes. Yep.
Layer structure too?
Yeah, you can see exactly like what's gonna deform, how much it's gonna deform, and then you can compensate for it. That one's a little more pricey, but of all the simulation software out there, it's probably one of your cheaper ones, but it's still pretty pricey. But a lot of people are starting to get into it though.
Yeah, I imagine it's important if you're building a sensitive part.
A good way of putting it, somebody says is, I forget, the average cost of, if you're like a production facility or even R&D, your average cost, if you calculate your cost of a build, let's say it takes you 3-4 days of building and it fails. And if you had simulation to figure this all out before it failed, you just probably paid for the cost of your simulation. You guys are going to be using the build processor, so you'll have a little tab like this that comes up. You would come over and hit build. You would fill in, let's see here, so this is a 290 build processor. Yours is going to say 280. What do you want to do? You want to build it, you would give it a name, configure the machine. So if you leave everything at like 10 millimeters or 10 microns, you're going to be fine. And then when you submit this job, it's going to save it as a project. Slicing, direct part,
So when you submit the job, submit to, is that save on somewhere in the desktop file or?
Yeah, it should be, here it is. So I don't know why I didn't do this the first time. It should give you where you want to save it. Or, it should ask you where you want to save it to a folder, and then from the folder, you guys aren't going to be connected directly to the machine. So you're going to save it actually on the USB, and then the USB you'll put it into the machine. Why it's not oh, that's what it is. It's pre-process only. So here's where I would come over here and I would pick where I want to save it. And then submit, and then here's it. look, you're gonna see it saves it as, should have saved it. Still don't see it. Oh, stuck it in made a folder, that's what it is. I just left it untitled. So if you go in the untitled, there's the, everything that saves, you can see it saves it quite a bit. So it's saving you there's your two slice files that you need. It's got a text document, I think it tells you exactly what you did with your part. It's got this platform, and so what this platform means is it saves the whole job in Magix. So whenever you open the platform, it's going to bring in the support with the part.
That's still the platform.
Yeah. And I don't know what this XML, what this really is used for. Which, the main two things that's important for you two, for your PSW, is going to be your two slice files.